Hello, dear friends in Choueifat School. This is Wael Bashuri, math and physics teacher. In this video, I'm going to solve this online quiz for week 10. Uh, so let's directly start solving first question. Choose the correct answer that completes the sentence. The motion in which the velocity of an object increases by equal amounts in equal time intervals is referred to as. This is uniformly accelerated motion. So you have to choose this option. Number 2, a train moving along a straight track accelerates from rest at 2 meters per second squared for 20 seconds. It then moves at constant speed for 2 minutes and finally decelerates uniformly to a stop in 10 seconds. Choose the correct answer to complete the sentence below. The net displacement, what is it? In order to calculate the net displacement, the best way is to draw a small graph quickly and then you can find the area under the graph. So let's do this graph here. It's moving at constant acceleration, which is 2 for the first 20 seconds. So let's assume here you have 20 seconds. And since it's moving at constant acceleration, which is 2, this means the slope of the graph here must be 2. So if the slope must be 2, clearly here we have to write 40, that's the velocity meter per second. 40 because rise over run must be 2, which means 40 over 20 must be 2. And then it moves at constant speed for 2 minutes. 2 minutes means 120 seconds. So you have to draw a horizontal line here for the first, for 120 seconds. This means here you have now 140. And last part or last stage of the journey, decelerate for 10 seconds. Decelerate for 10 seconds means here you have to write 150 seconds because 10 seconds means from 140 to 150 is 10 seconds. So these are the three stages in the journey. Now to find the displacement, you have to find area of trapezium, area under graph. So area of trapezium or trapezoid is equal to base 1 plus base 2 over 2 times height. So area is equal to base 1 is 150 plus base 2 is 120, that's base 2, that's base 1. And this is the height from here to here. The height is the distance between the two parallel bases. So 150 plus 120 divided by 2 times 40. That's what you have to do. Let's see now. Next question, number 3. A car moving at speed of 4 meters per second accelerates for 2 meters per second squared for 3 seconds, then moves at constant speed for 2 seconds, and finally applies the brakes, hence decelerating uniformly for 5 seconds until it finally stops. The motion of the car summarized in the velocity time graph below. The area and the graph between t equals 0, t equals 3 is what? So in order to find the area here, we can divide into two trapeziums. So let me draw this line like this. Now here you have two trapezium, area 1 and area 2. Now for area 1, as we said in the previous question, base 1 plus base 2 over 2 times height. This is base 1 and this is base 2. Now base 1 is 10 and base 2 is 4 over 2 times the height, which is in this case 3. So that's the height from here to here. Plus, So this is area 1, leave it here. Now area 2, this is area 1. Now area 2 is equal to base 1. In this case, this is base 1. Be careful, the bases are the parallel, and this is base 2. So base 1 is from 3 to 10, which is 7, plus base 2, which is from 3 to 5. Here you have 5. From 3 to 5, it's 2. This distance is 2. So plus 2 divided by 2 times the height. The height in this case will be base 1 in the previous area. So the height, here you have now the height from here to here. That's the height, which is in this case 10. So the height is 10. Now you add these two quantities and you put them here in this box. The area under the graph from 0 to 3. They want here the area from 0 to 3 only. Okay, they want only the first area. They don't want the total area. If they want the total area, you can add these two. But now the answer is just what you get here. 10 plus 4, you get 14 divided by 2. 14 divided by 2 is 7 times 3, 21. So here you have to write 21. And then they ask you about the distance covered during the first 3 seconds is also the same thing, 21. So remember, they just want this area. They don't want the total area. Okay, let's now see question number 4. Also you have here velocity time graph. At which interval does the formula applies? It applies in the first interval here from here, first interval from 0 to 5, because here you have constant acceleration. So you have to say from 0 to 5, the interval from 0 to 5. At which interval does the formula x vt when constant speed? Vt, x equal vt here, when the graph is horizontal or it's moving at constant speed. Next question. Total distance covered by the car during the 9-second interval. Total distance means area under graph. So 9 seconds means you have to draw this line like this. And then you have to find this area. So area equal to base 1 plus base 2 over 2 times height. So area is equal to base 1 is 9 plus base 2 is from 5 to 9, which means here base 2 is 4. So plus 4 divided by 2 times the height, which is 30. So that's what you have to do for the displacement or the distance traveled in the first 9 seconds or in the whole journey. Now the velocity of the car at 3 is what? Velocity at 3, you can directly read it from the graphs. Here you have 3. You go vertically, then you read it from the graph. Very easy. Next question. The highest velocity of the car in kilometer per hour. Highest velocity clearly 20. So you have to convert 20 meter per second into kilometer per hour. 20 meter per second into kilometer per hour. Divide the top number by 1000 to make it kilometers. Divide 1 second by 3600 to make it 1 hour. Put bracket up and bracket down and get the answer from the calculator. Question number 5 now. The graph below represents the VT graph of a motorcycle in 24 seconds. Complete the following table. Now at the time 2 seconds was the velocity. So here you can easily read it from the graph. When the time is 2, the velocity is 12. So here you have 12. When the time is 4, The velocity is 24. So here you have 24 and so on. Next question. Drag and drop the correct time interval in each case. The velocity is positive. Okay, the velocity is positive whenever it is above the x-axis, like this. Here, from 0 to 15. So here you have to choose from 0 to 15, the velocity is positive. Now the velocity is negative when it is below the x-axis here, this part. In this part, the velocity is negative. So from 17 to 24, the velocity is negative. And then the velocity is positive and decreasing. Positive and decreasing means this part here, this part is positive and decreasing because it's going down and it's above the time axis. So this means from 12 to 15. So you choose this option. Now in the interval from 12 to 15, the rate at which the velocity decreases is what? From 12 to 15, we want the rate of decrease of the velocity. So here you have to do rise over run, the slope formula. Rise over run. Rise we have it 24 and run we have it from 12 to 15, which is 3, which means the answer must be 8. Question number 6 now. Identify the motion of the particles for each position time graph. Choose the correct answer. Okay, first one here you have position time, which means distance time. The object here is stationary, it's not moving. So here I have to choose not moving. Here, constant velocity or constant speed. And here it's accelerating. So here you have accelerating. Question number 7. Here you have to fill the blanks. If the a car is moving down a horizontal road, take north as positive sense. So north is positive. Okay. So if the car is moving at 2 meters per second squared due north, then the car accelerates at rate 2 meters per second every second in the positive sense. If the car is moving at negative 2 meters per second squared south, then the car is accelerating 2 meters per second every second in the negative sense. So here also accelerates in the negative sense. If the car is moving negative 2 meters per second due north, be careful, due north means positive. So then the car is decelerating. So here decelerating in the positive sense. Very easy. Question number 8. Now, the tangent at point A, 10 seconds, 5 meter, passes through point B, also 4, 0. It's not 4. Let's see what's this. Here it's not 4. It's 4, 0 and 10, 5. 4, 0 and 10, 5. So let's write them on the diagram. So here you have 4, 0 and here you have this point is 10, 5. Okay, what's the speed of the object at point A? You have to do the slope formula. Slope x2 minus x1 divided by t2 minus t1. So 5 minus 0 divided by 10 minus 4. 5 over 6 meter per second. 5 over 6. That's what you have to choose. Okay. 5 divided by 6, 0.83. That's the answer. Now next one. The velocity time graph for a moving object is shown below. Drag and drop the correct terms for the box below. In the phase AB, the object is speeding up. This is very clear from the graph. In the phase BC, constant speed or moving uniformly. So choose this option. CD, slowing down. And then in phase DE, moving uniformly or constant speed. Number 10 now. The initial velocity of a car is 20 meters per second. It decreases to 2 meters per second in 3 seconds. Drag and drop the terms from the box below. The average acceleration is the change in the object velocity over time. So acceleration is change in velocity over time. The average acceleration of the car is, we calculate the change in velocity, which is, we are given initial velocity 20, so acceleration is final velocity minus initial velocity divided by time. Final is 2 minus initial is 20 divided by time, which is 3. Next question, number 11. Consider the position time graph below a moving particle. What's the average velocity of the particle in the time interval from 0 to 3? Now, from 0 to 3 means here you have 3. You have to take 2 points. Average velocity is delta x over delta t. So velocity average equal delta x over delta t. So you have to take this point here, which is 3, 2 and 0, 0, because we're saying q from 0 to 3. So now you do the slope formula. 2 minus 0 divided by 3 minus 0. 2 over 3. So the answer is 2 over 3. Next question now, number 12. The average acceleration of the particle in the time interval from 0 to 4. Now, from 0 to 4 means you have to take this point, 0, 0, and this point, 4, 0. And then you do the slope formula again. Number 13. The instantaneous acceleration of the particle at t equal 4. So instantaneous here, instantaneous acceleration here. What you need to do is to take 2 points and find the slope again. So here, this point is 4, and then you have to calculate for what here. This is 5 divisions. So 0 0.4, 0 0.6. You have to divide 2 by 5 divisions. So each division, 2 divided by 5 divisions. Each division will be 0 0.4. So 0 0.4, 0 0.8. So here you have 0 0.8. Okay. 0 0.8. Here. That's the first point. Let's take another point. For example, let's take this point here. This is a clear point. So let's read it. Coordinates. Here you have from 1 to 2. This is 1.2, 1.4, 1.6, 1.8. Yeah. So this is 1.4. So here the coordinates is 1.4, 1.4, and 4. Also now you do the slope formula. V2 minus V1 over T2 minus T1, and you get the answer. Question number 14. The displacement of the particle in the time interval from 0 to 4 is what? Here you have to do area on the graph. Remember, this is also a trapezium. This is base 1, this is base 2, from here to here. And the height is from here to here. So area is equal to base 1, which is 4, plus base 2, which is 2, divided by 2 times the height, which is 5. Question number 15. A stopwatch is turned on as the toy car passes x equals 3 mark on the track. The toy car is moving in the negative direction. It's moving to the right, to the left, at constant speed 0.4. The position of the toy car at 2 seconds is what? Okay, at 2 seconds, after moving 2 seconds, it's constant speed, so x equal vt. This is for the formula for constant speed. You multiply 0.40 times 2, so you get 0.8. Initially, now it is at 3, and here you have 2. If it moves 0.8 meters to the left, so this is the distance moved to the left, 0.8 meters, it means it will be at 2.2 here. So the answer, the position will be 2.2. Question number 16. A toy car initially moving at 2.50 meters per second in the positive direction. It starts decelerating at rate 0.20 meters per second squared. The average velocity of the toy car 2 seconds later is what? So here you have to use the equation v equals at plus u. V is equal to a, the acceleration, which is 0.20, time is 2, is 2, and the initial velocity is 2.50. But because it's decelerating, so the acceleration must be negative. So negative 0.40, negative 0.40 plus 2.50. On the calculator you get the answer. Now question number 17. Cyclist passes the start line with a speed of 2.80 in the positive direction while accelerating at constant rate which is 0.2 meter per second squared. Choose the correct answer to complete the sentence. The displacement of the cyclist in 20 seconds is what? So here you have to find the displacement. So here you have to use delta x. Delta x is equal to half at squared plus ut. This is the way you find the displacement in case you are given the acceleration, the time, and initial speed. So half times the acceleration is 0.2, the time is 20 squared plus initial velocity is 2.80 times the time, which is 20. Question number 18. The average acceleration of the ball during the 3 seconds to 1 decimal place is what? Average acceleration is the slope of the speed time graph. So 0, 0 and 3, 1.8. 0, 0, 3, 1.8. You have to do the slope formula and get the answer. What can be said about the acceleration of the steel ball? Choose the correct answer. Here it's increasing at speed is increasing at constant rate, so you have to use constant acceleration. The acceleration is constant. Number 19. The table below shows the position of the cart at different moments. Drag and drop the correct answers to complete the sentences below. The average velocity of the car over the time interval from 0 to 7 is what? So average velocity from 0 to 7, you have to use also the slope formula from 0 to 7 here. So you have 2 points, 0, 0 and 32, 7. You do slope formula. Average velocity or velocity is equal to 7 minus 0 divided by, here you have to do here the time first. So this is 732. So let's repeat this. This is here 0, 0 and 732. So now you do the slope formula. 32 minus 0 divided by 7 minus 0. Then you get the answer. Number 20 now. Select the VT graph that describes the following motion. A car accelerates from rest in the positive direction, then moves at constant speed before slowing down and going back to rest. Clearly, this is the option. Acceleration in the first part, then constant speed, then slowing down. Question number 21 now. The average acceleration of the particle in the time interval from 0 to 5. From 0 means here you have 0, negative 5, and to 5 means this point here, which is 5, 4. You do slope formula. 4 minus 5 divided by 5 minus 0. Next question, number 22 now. The graph below shows the velocity of a particle at different moments of time. The instantaneous acceleration of the particle is what? Instantaneous acceleration at 1. Here you have 1, you go to the graph, you do the slope formula, or you can do rise over run directly. 12 over 2, this is rise, this is run. Rise over run, 12 over 2, 6. The instantaneous acceleration of the particle at t equals 3. T equals 3 means here. Also you have to find the slope of this line, or you can do rise over run again. Rise is 12, and run is from 2 to 5, which is 3. So 12 divided by 3, 4. But because we're asking about acceleration and it's decelerating, so you have to write it negative 4. Number 23 now. A particle initially at point with coordinate negative 2 is moving towards the origin at constant speed of 5 meters per second. In 10 seconds, the position of the particle will be what? Initially, the particle is here at position negative 2 and it's moving at constant speed, means the equation x equal vt, that's the equation for constant speed, or the same equation you took in grade 6, 7, speed equal distance over time. You can also use it. Anyway, so in 10 seconds, what is it? So let's calculate the displacement in 10 seconds. The velocity is 5 times 10, which is 50 meters. So now it must move 50 meters to the right. So after moving 50 meters to the right, this is 50, it will be at a position of 48. Because it started negative 2, moving 50, it will be at 48. So here, the position will be 48. Be careful, they want the position, not the distance. So now, number 24, a particle at origin starts from rest and accelerates for 2 meters per second. The particle will be 81 meters away from origin in what time? In what time? So here you are given the acceleration and you are given the distance. So you can see S equal half a t squared plus ut. S means delta x. You can write it delta x or s, so delta x. Okay, half the acceleration is 2 times t squared. That's what we have to find. And we are given the question that delta x is 81. You can cancel 2 and 2. T squared is equal to 81, so t equal 9 seconds. Question 25 now. So here you have a graph, the average velocity in the time interval from 0 to 4. from 0 to 4 to one displace, what is it? You have position time graph, you want average velocity from 0 to 4. So you have to find the slope, 0, 0 and 4, 15. 4, 15, you find the slope formula. Instantaneous velocity at 2, here at 2, also the slope, but now the slope of the tangent. Initially, for question A, slope of secant, but now slope of tangent. Also you take 2 points on the graph, like 2, 2, 3, and then here 1, 1, 0, then you do the slope. So in both cases you do the slope, x2 minus x1 divided by t2 minus t1, and then you find the requirement. Number 26 now. A truck accelerates uniformly from rest at 1 meter per second squared. What is the distance covered by the truck when it reaches a speed of 72 kilometers per hour? Choose the correct answer. So here we have to find the distance. So first step here you have to do is to convert 72 kilometers per hour into meter per second. 72 kilometer per 1 hour. You have to convert it into meter per second. So multiply by 1000 up to make it meter, and multiply by 3600 down to make it second. Now if you calculate this, you can get 20 meter per second. Then you have to use the equation of motion, which will give you the distance. You have acceleration here, and you have initial speed u or v1 equals 0, and you have final speed v equal 20. So now you have to find displacement. Delta x is equal to, we don't have time, so let's use v squared equal u squared plus 2a delta x. So final velocity is 20, initial velocity is 0 because it's moving from rest. 2 times 1, the acceleration, delta x we don't know. Question 27 is last question now. The land safely a jetliner decelerating, to land safely a jetliner decelerating uniformly at 7 meters per second squared needs a runway with minimum length of 500 meters. What's the maximum touchdown speed of the jetliner? Okay, so for the jetliner, final velocity must be 0 because after moving on the runway it stops. The distance moved must be 500 meters. That's the distance of the runway. The touch speed, we don't know. That's initial speed, we don't know. We know that the deceleration is 7. So here you do v squared equal u squared plus 2a delta x. We have to find initial velocity, so 0 squared. Initial velocity, we don't have it. 2 times the acceleration, we write it -7 because it's decelerating, and here we write 500 meters. Then you can solve this equation to find the initial velocity after doing square root of u. Thank you very much indeed for watching my videos. Don't forget to subscribe to my channel.